All right, good evening. Welcome back to pre-calculus. All right, this is problem number 5, I believe, for our pretest. And in this one, we have a system of equations that they give us a system, and they tell us, by the way, check to see whether or not -4, -1, -4, 3 is a solution. I am not asking you to type in -1 for x, -4 for y, and 3 for z to make sure it works. Okay, you've already done this. You did this in Algebra 1 or in college algebra or intermediate algebra. I'm not asking you to verify this is a solution. What I'm asking you to do is prove it's a solution by using row operations to show me that the solution looks like a solution looks like this. Okay, because of the way this thing is worded, I have a feeling that we actually have an infinite system or a dependent system, and we're going to see whether or not this actually works for me. So here we go. So we have this system of equations, and as usual, what I'm going to do is I'm going to say, I want to get rid of all of my x's first. So I'm going to say, we're going to say negative row 3 plus row 1. And now we're going to put that into a new row 3. Okay. I'm not touching row 1. I'm leaving that alone. So we could just write row 1 back over again. X plus 2y plus 4z is equal to 3. Delightful. I'm not going to be touching y, the second row on this first step at all. So we can go ahead and say this is y plus 3z is equal to 5. Okay. And then what we're going to do is I'm going to say negative x plus x. And there's nothing left. We have -0 plus 2, so we have a plus 2y here. And I have a negative, negative. So we have negative, -2. So it's going to be positive 2 plus 4z is going to give me 6z. And then we have -7, negative, -7. So it's going to be a positive 7 plus 3 is equal to 10. All right. At that point, I'm looking at this. I'm like, okay, well, one thing you can do is we can go ahead and multiply by a constant if you'd like. And I'm just going to do that to keep my numbers small. So we're just going to go ahead and rewrite this. You don't have to make this step, but this is going to be x plus 2y plus 4z is equal to 3. And I have a y plus 3z is equal to 5. And when I go through and multiply that by a half, I have 0 plus y plus 3z is equal to 5. Oh, would you look at that? So I'm going to say row 3 plus row 1, or negative row 3 plus row 1, back into row 3 and see what I end up with. Okay, so we have x plus 2y plus 4z is equal to 3. I have y plus 3z is equal to 5. And then when I go through and say negative row 3 plus row, I'm sorry, plus row 2, to row 1 to row 2, negative row 3 plus row 2, we actually end up with 0 x's plus 0 y's plus 0 z's is equal to 0. Well, no kidding. Anything I pick for x, y, and z will be just fine here. So when we have a row of zeros, we get a free variable. So we're going to say set x3 equal to t. All right, and then we're going to solve the equation as a dependent system in terms of t. So we're going to say, okay, roll this up to, so we've effectively solved row 3. Just said, okay, z is equal to t. We're going to roll this up to row 2. So I'm going to say y plus 3t is equal to 5. Therefore, y equals 5 minus 3t. All right. And now that I've got that done, we're going to take row 2 and we're going to roll it up into row 1. So in row 1, I have x plus 2y. So we have 5 minus 3t here, plus 4z was t is equal to 3. All right. So all I did was replace my y's with what I found for t. I replaced my z with what I found for t. And we're going to go ahead and simplify this a little bit. So I have x plus 2 times 5 is 10. 2 times 3 is negative 6t. Okay. We have a plus 4t, and this is equal to 3. Let's see what happens. We have x plus 10, negative 6 plus 4. We have a minus 2t is equal to 3. Let's go ahead and subtract 10 from both sides. Let's go ahead and add 2t to both sides. So we're going to say x is equal to 2t, looks like minus 7. Okay, so my solution set, okay, is going to look like a set of things that look like 2t minus 7. What was my y? 5 minus 3t, and then t. So anything that looks like 2t minus 7, 5 minus 3t, t, that'll work for my solution. What numbers were we supposed to check? We were supposed to check to see if, auto back up here, -1, -4, and 3 was actually going to work out. I'm going to go out on a limb here. I'm going to say set t equal to 3, and let's see what happens. Okay. So if I have my solution here when t is equal to 3, we have 2 times 3 minus 7. I have 5 minus 3 times, I'm sorry, 5 minus 3 times 3. And then we have 3. So we have 6 minus 7. We have 5 minus 9. And we have 3. Well, 6 minus 7 is -1. 5 minus 9 is -4. And then we have 3. What points was I supposed to be checking on? I think it was, let's double check. -1, -4, 3. Hey, would you look at that? That's exactly the situation I find myself in. So my solution here, 2t minus 7, 5 minus 3t, t. Okay, you can write these any way you'd like. It's okay, because addition commutes, so you can write them forwards or backwards. It's up to you. Okay, I wrote them this way, so that's what we're going to deal with. And we checked our answer, and we're going to see. Okay, here's my answer, right? Here's my general solution right here. Okay. And we checked one of my problems here and checked one of our points. We could generate an infinite number of these, but we checked one of the points. We made sure that one worked. We verified that as a solution, but we did it with our row operations. And that's pretty much how we go through and solve a problem like this. So I'm going to say thank you very much for watching the video. It's fun to do these problems, and good luck studying, and I will see you in the next video. All right, take care.